Hello, welcome to Engineering Class again. Now we're talking about polar and rectangular coordinates. So let's talk about them. Okay, so you may know rectangular coordinates. You've seen the Cartesian plane, you've seen the XY plane. We're all familiar with that. Like you might get something like you go over four spaces or 4 units to the right, then you go up three units and you have your point. Now we also have polar coordinates. So why would you actually want to consider polar coordinates and what are they used? Imagine if you had to locate the tip of the hour hand at any given time. Let's say 1:20 p.m. How would you do that? When you see the hour hand rotate around, you can see that's incremental. So you can't really have a nice form 3 units to the right, 5 units to the up or down. So you'll see how polar coordinates really helps you. And over here, how we start is we just think about converting the time to minutes. So we have it to where we have 1:20 p.m. And since it's one is around the 5th minute mark. So 5th minute mark plus the 20, which is 1/3 of the 5 minute intervals that we have, and we come up with 6.67 minutes. Okay, now the next thing we need to know is we want to be able to convert this to seconds. So we convert seconds by identifying that there are 3,600 seconds in an hour. An hour has 60 minutes, therefore we have 60 seconds in a minute. I change units, but MIN is the same as M. Sometimes I change back and forth. But so we have minutes. Now we want to go from minutes to seconds. How do we do that? We take our 6.67 minutes and we use our conversion factor of 60. No, it's not minutes. It's 60 seconds per minute. And we just multiply that out. Once we multiply that out, 60 times 6 is about 360. 60 times 7 is about 420. Let's just approximate, say, 402 seconds. Now, here's the last part. We have to convert seconds to degrees. Now, this is kind of difficult. How do you convert seconds to degrees on a clock? Well, luckily, we can just use a conversion factor of 1/10 seconds per degree. And what that'll do is give us 40.2. Once I get this down, equals 40.2. And that works out really, really nicely. So all we have to do is convert the hour hand to the equivalent seconds and divide it by 10. And who came up with this? The ancient Sumerians. For some reason, I'm not sure if there's ever been a connection, but they knew there's something really nice and logical about having 60 seconds in a minute and 60 minutes in an hour. So anyway, we have 11.5. We take that as our radius, but the clock is about 12 inches in radius. So let's just say 11.5 because it's going to be a little bit inside. There's going to be a little offset. So let's just say it's 11.5 on our 12-inch clock or 12-inch radius clock, and the angle is 40.2 as we just calculated. So now what we need to do, we need to calculate the rectangular coordinates. Now, how do we do that? Rectangular format, you have x is equal to r cosine theta. And if you don't know what x is, we're going to have a format of x plus jy, and that's going to be our rectangular coordinate format. And so we have r equals to cosine theta equals 11.5 cosine 40.2 degrees. Then we have y, which is equal to r sine theta, and that's equal to 11.5 sine 40.2 degrees. Now, the next part comes, which is pretty difficult because we have to calculate the cosine of 40.2 and the sine of 40.2, and that's not very intuitive. And you probably don't know how to calculate it in your head. So I'm going to show you a quick mnemonic. And it's a way that you can calculate this without really knowing, or not really knowing, but calculate this without really having a calculator. So here's a trick. Okay, you just put down some 2's, and we're just going to populate this whole field with 2's. Then we're going to take some degrees, some intervals. So we're going to do 0, 30, 45, 60, and 90 degrees. Now, what we're going to do here, we know that sine 0 is equal to 0. We know that cosine 0 is equal to 1, right? So we just go 0, 1, 2, 3, 4. And I didn't just come up with this, but this is something that's a trick I learned somewhere. So you might want to remember this through the rest of your career because it might come in handy. Then for cosine, you just have 4, 3, 2, 1, 0, and they're all in square root signs over 2. And so we need to calculate what that is. So first of all, we realize or we recognize that 45 degrees is not too far from 40. And it's not quite 30, but somewhere between 30 and 40. So we can calculate what 45 degrees is, and that is equal to 1.41 over 2 is equal to 0.707. And so we have sine is equal to anywhere between sine 30, which is 0.5, anywhere from 0.5 to 0.707, and cosine is equal to anything from 0.707 to square root of 3 over 2. Square root of 3 is 1.732 divided by 2 is equal to 0.866. So we'll choose something a little bit lower than 0.707, which is, let's just choose 0.68, and something a little bit higher than 0.707, which is 0.73. So we can just use that. We plug it back into our formula for our polar to rectangular coordinates. And once we do that, we just do 11.5 times 0.73 and also 11.5 times 0.67. Now we don't want to use a calculator. We're just going to run through this as a quick rough example. So we'll realize that, okay, it's 0.73. You can divide it by 4 parts, but we're only going to take 3 of them because 3 divided by 4 is 0.75, which is roughly 0.73. And same thing with 0.67. We can have 3 parts. We're only going to take 2. 11.5 is close to 12. If you divide 12 by 3, you get 4. So 4 times 2 and 3 times 3. You have about 8.5 and 7.5. So 8.5 plus J 7.5, which is in the format that we spoke about earlier, which is X plus J Y. Now we go to the rectangular coordinate system and we go to the rectangular Cartesian coordinate plane. We go 8.5 inches to the right, 7.5 inches up, and that gives us an angle of 40.2 because we calculate that using the polar coordinates, and the length would be 11.5. There you go. That is the rectangular to polar conversion. You can see that they both ended up at the same spot if you were just to use the hypotenuse and the angle, or if you were to use the X and the Y, they end up at the same spot. Now, for the clock, you might realize that things are a little bit different because the clock actually begins at the 12 o'clock hour, right? But that's equivalent to the 90-degree mark on our rectangular coordinate system. So what we have to do, what we call a phase shift. Okay, how we do that? We just have it's shifted by 90 because actually the x-axis is going to align with the 12 o'clock hour. So that's 90-degree change. So we say 90 minus 41, and that equals 49. So actually, if we want to plot it on the same coordinate scale, we would plot it using 49 degrees. So once we do that, we just plot it using 49 degrees. And what we want to do after this, and you can see where I marked 0 and 90 for my rectangular coordinate system, or for my Cartesian coordinate, and 0, 90 for my polar. Now we go up 8.5, and which is on the adjacent. Then on the opposite, we go to the right 7.5 inches, and there we go. We plot it in the location that we need to have for 1:20 p.m. So we're done, and we just circle the corresponding corners, and that's it. That's how you convert from polar to rectangular, and that's what they signify. Thanks. Bye.